Hello everybody, welcome back to my YouTube channel. I'm Anushka, currently studying in Sri Venkateswara College of Engineering, Bangalore, and I'm in third sem. I'm belonging to CSC Data Science. Today we'll be discussing about evolution of digital IC technology. Introduction to Digital IC Technology. IC here stands for Integrated Circuit. Before getting on to integrated circuit, we'll be looking into transistor. Basically, transistor is a crystal or an electronic device which controls the flow of electron required to our desire. Before transistors came about in 1940s, and before that we had vacuum tubes which were very bulky and non-reliable. Hence, we moved forward with the transistors. Transistors evolution or development of transistors lead to IC, which is digital IC, which is integrated circuit. Digital integrated circuit IC technology has evolved significantly over the years. It originated in the mid 20th century after the transistors and hence has since revolutionized the field of electronics. So basic concepts are digital IC technology involves the design and fabrication of integrated circuit that performs digital functions. These circuits are composed of transistors, as mentioned earlier, are electronic circuits which control the flow of electron. Resistors are the electronic devices or electronic circuits which resist the flow of electron as suggested in the name. Capacitors are basically electronic devices which stores the electrons and other electronic components. We're looking into different generations of ICs. First, we have first generation small scale integration SSI. The first generation of digital IC technology is known as small scale integration. It involves integrating a small number of transistors into a single clip. This single clip is made up of silicon. We're looking at the key features. Number of transistors, here we have only 100 or usually less than that. Functionality is the production was simple, though it was expensive. Size is really small relative to other generations out there. Power consumption, since it was primitive, that was made early on, it consumed really lot amount of power due to limited integration density. That is, the density was low, even though despite the fact that density was low, the chip consumed a really high amount of power, which made it not desirable. Cost, it was expensive to produce due to the manual assembly process and low yield rates. Reliability was really less or comparatively less to later on generation which developed. We'll be moving on to the second generation, which is medium scale integration. The second generation of digital IC technology is known as medium scale integration MSI. This generation involves integrating a moderate number of transistors onto a single chip. The single scale integration had around 1,000 or less in transistors, whereas here we have moderate number of transistors on a single chip. This chip can be made up of silicon. MSI was a significant advancement in IC technology, allowing for more complex and sophisticated electronic system. Let's look into the key features. So we have features, number of transistors, moderate number of transistors integrated onto a single chip, typically in range of hundreds to thousand. Functionality was capable of implementing more complex logic functions and circuits compared to the previous generation, that is SSI. Component count, reduced component count as multiple functions are integrated onto a single chip, resulting in a smaller and more compact electronic system. Power consumption, relatively low power consumption compared to the previous generation, enabling more power efficient devices. The cost is less as compared to the previous generation, and the previous generation was manually integrated. And in this, we have better technology and it becomes more accessible and affordable. This is what is the trend with more and more development, that is over the years the pricing reduces and the efficiency increases. The applications are used in a wide range of applications, including the calculator, digital watches, earlier microcomputers, and other electronic systems that require moderate complexity. Moving on to the third gen, that is large scale integration technology known as large scale LSI. Basically the acronym is LSI, large scale integration. A large number of transistors are integrated onto a single chip. This advancement allowed for even greater miniaturization, that is minimizing it, and increased functionality of electronic devices. We'll be looking into the key features of LSI. First, we're looking into transistor count. The integration of thousands to ten of thousands of transistors onto a single chip. As the generation is increasing, the transistors present in the single chip, the chip that we're talking about is of silicon, is increasing. Miniaturization is again, as I'll repeat, minimization, significantly reduced size of electronic device, enabling portable and compact designs. Increased functionality. So ability to incorporate more complex circuits and feature onto a single chip has increased. Improved performance, enhanced speed and efficiency of electronic device due to increased integration and reduced signal propagation delays. Here also the power consumption is reduced and power efficiency is increasing. The cost reduction has happened here, as the first generation was manually equipped or manually connected. Here the lower manufacturing cost compared to the previous generation in making a digital IC technology more accessible. We'll be looking into the fourth generation, which is very large scale integration. VLSI is the abbreviation. The fourth generation of digital IC technology is known as Very Large Scale Integration, or the abbreviation VLSI. This generation marked a significant advancement in chip design and manufacturing, allowing for the integration of a very large number of transistors onto a single chip. VLSI technology revolutionized the electronic industry by enabling the development of more complex and powerful electronic devices. We'll be looking into the key features and characteristics of VLSI, the transistor count. So here the transistor count has increased. VLSI chip can contain 10 of thousands to million of transistors, allowing for complex and highly integrated circuit. The size here has significantly decreased, smaller in size to previous generations, enabling development of smaller and more portable electronic devices. Basically, the miniaturization or the minimization of the size has increased. Power efficiency. Well, VLSI technology allows for the design of power efficient circuit, reducing energy consumption and extending battery life in electronic devices. The performance. The higher transistor count and integration density of VLSI chips enable more faster and more powerful electronic device with improved performance. The cost. VLSI technology has contributed in significant reduction of the cost of electronic devices, making them more accessible for a very wide range of consumers. The applications are have been widely used for various applications like microprocessor, memory chips, digital signal processor, application specific integrated circuits are also known as ASICs. Moving on. We have the fifth generation, which is the ultra large scale integration, ULSI. The fifth generation of digital IC technology, as also known as ultra large scale integration, ULSI is the abbreviation. It represents a significant advancement in the semiconductor manufacturing, enabling the integration of an extremely large number of transistors onto a single chip. This chip again is of silicon. This breakthrough in technology has revolutionized the electronics industry, leading to the development of a more powerful and efficient electronic device. Be looking into the key feature and characteristics of ULSI. The transistor count here contains to a billions of transistors, allowing for more complex and highly integrated functionality. The miniaturization. ULSI technology enables the production of smaller and more compact electronic devices, leading to an increased portability and convenience. Increased performance. With a large scale transistor count, ULSI chips can perform more complex calculation and execute tasks at a very faster rate. Power efficiency. are designed to be more power efficient, reducing energy consumption and extending battery life in a portable devices. Cost reduction, the integration of a large number of transistors onto a single chip reduces the overall manufacturing cost, making the electronic device more affordable. Advanced functionality. ULSI technology enables the implementation of advanced features and functionality such as artificial intelligence, machine learning, and high speed data processing. Artificial intelligence and machine learning have become a major domain in advancement as well as daily lives in this generation. Now we'll look into the naming pattern of these IC technologies. In earlier cases, due to lack of standardization, naming had become quite a question. But with as the time went on, there was standardization and naming had become easier. First generation is known as TTL transistor logic. TTL was the first widely used digital IC technology. It was characterized by low power consumption and high noise immunity. We have a series known as 74XX. The 74 describes or translates to TTL transistor logic, and XX could be of any subscript like S, N, HC, HS, and so on. Second generation ECL, emitter coupled logic. ECL offered faster switching speeds and higher circuit density than TTL. It was commonly used in the main framework computers in high speed application. Third generation CMOS. CMOS stands for complementary metal oxide semiconductor. Technology became popular due to its low power consumption and high integration density. It is widely used as the modern digital ICs. The fourth generation by CMOS, bipolar complementary metal oxide semiconductor is the full form. By CMOS combined the advantages of both bipolar and CMOS technologies. It offered a very high speed performance and low power consumption. The fifth generation is FinFET. Fin field effect transistor is the full form. FinFET technology introduced a three-dimensional transistor structure and enabling even higher integration density and improved power efficiency. Sixth generation is nanosheet, which is the upcoming generation. Nanosheet technology is currently being developed as the next generation of the digital IC technology. It promises further improvement in the efficiency and the performance. Thank you so much for being a part of this journey. I hope this video was knowledgeable. I'll see you in the next one. Till then, take care. Thank you.